and Philip would be one. So when we were choosing a project, we were inspired by an MIT hackathon that was put on recently called Build a Breast Pump That Doesn't Suck. Figuratively. So breast pumps in general are a vital piece of medical equipment for children who can't nurse naturally, but the technology really hasn't changed since the 80s. Very little changes have been made in that process. And we set out to hopefully make something better that could be more useful for mothers. So first we conducted a survey of about 100 mothers and asked them if they were satisfied with their breast pump and what they would like to see incorporated. And we found in general they were moderately satisfied but had a lot of complaints. So some of the things that they felt would be really helpful to see were a quieter breast pump. They said that often the noise was really loud and irritating. They wanted something that was portable. They wanted something that was reliable, but they also liked the idea of bringing it into the modern world. So incorporating it into a web interface and incorporating the trends of the Internet of Things. So during our first semester, we created a prototype. So a prototype was basically a motor. It was driven by a microcontroller. We used a TI Launchpad. It was also attached to a sensor that measured the volume of liquid that was pumped. The Launchpad was then connected to a Wi-Fi booster, which then transmitted data from the board to a MySQL database, which was then displayed on a web page. So we created a working prototype the first semester, and the second semester set out to make some great improvements. So first of all, Philip was involved in taking our proto board and rat's nest and making it into a PCB so that it could be more reliable, more portable, and just a better product overall. Richard was involved in creating a 3D model, which we then printed, creating a custom enclosure. So part of the purpose of that enclosure was to make it, again, more portable, just generally more visually appealing, but also soundproofing. So we used some soundproofing foam and made some adjustments with measuring the sound of different motors and choosing an appropriate motor for that sound system. I worked on the website of things. I created a mobile-friendly website that automatically updated and added some charts so that you could see some more information about it, and then to be integrated eventually into a user system where every user could log on and see their own data. In addition, we added 2 lithium polymer batteries so that the entire system could be run for about 20 hours on a single charge, which for the average user is about 3 days of pumping. So a final caveat is that in order for this to become a production device, we realized that it would be classified as a medical device and we needed to undergo FDA testing. And of course, in this scope, we were unable to do that, but we did do a lot of research on the steps necessary for that. So, question? Yes.
How is Twitter involved in this?
Twitter Bootstrap is just a prototyping website framework. It's,
There's no tweeting that's going on.
Twitter actually made more than one product. Yeah, we thought about jokingly making a tweet, but decided it wasn't a good idea. Any other questions?
Well, it sounds like you increased the instrumentation. Was there any other benefits or differences that this has versus the normal ones?
As far as what, just a general feature?
Yes, I'm not that familiar with it, to be honest.
Sure. We mainly concentrated on the features that Kate listed. So beyond that, we just wanted to make sure that it was functional and it met the design requirements that our survey respondees said.
What would that be? Would you need a certain vacuum level?
Yeah. So for breastfeeding, you have a range of vacuum that an infant can produce, and there are actually 2 stages of breastfeeding. So on the first stage, you have a high vacuum where, the maximum comfortable vacuum that a mother can sustain is about negative 190 millimeters of mercury. And so that phase will stimulate the nipple, and then it'll reduce by about half the pressure when you're just regularly expressing milk after your nipple has been stimulated. For our testing, we just wanted to make sure that we were operating within a safe range. So we just used a cap for the pressure is created by a piston that goes in and out of the dome, and so we used a cap that could create a pressure within the range we felt was safe. And so we tested in a range of negative 70 inches of H2O, which is about negative 140 millimeters of mercury, approximately. And that was the stimulation phase. Because for our testing, we were using a baby bottle and not a human. So the nipple of the bottle couldn't really be stimulated. So we stayed in that high range, and we were able to basically maintain the functionality of the pump. You know, it doesn't express milk any faster than a normal pump, but it at the same time it's in a range that's comfortable and safe.
You mentioned the environmental sound level. How was that addressed?
Sure. So we wanted to see if we could use a different motor, potentially one that was lighter. So we tested out 3 different motors, and what we were looking for with the noise was just how much noise each motor produced, and we would just choose the one that produced the least amount of noise. So we chose one that was, we looked at one that was a more powerful motor, but that produced a lot much more noise, almost 6 or 7 decibels more. And then we wanted maybe one that was smaller and lighter, so we looked at a really small servo motor, but that one actually also produced maybe 3 or 4 decibels more than just ambient noise. So we decided to stick with just a regular DC 5-volt motor because the noise that it produced, you can hear it, but it's almost imperceptible. When we took measurements, it was only 1 decibel above kind of ambient sound, which is kind of not significant. So and then we just tried to improve that by adding some sand damping foam. In our enclosure, what I tried to do was compartmentalize the motor so it has its own compartment, and that way, you know, we could surround it by foam on all sides and try and use that as a way to also improve the sound.